Hey guys, Mr. Riz here to help you out on the very last part of the 3.5 notes. And this is how we can evaluate limits, both the positive infinity and the negative infinity, with functions that have square roots or radicals. I'm going to minimize my video here just because those lights are distracting, but this is what we need to do. Remember, when we evaluate limits, we're checking to see where the higher degree is. Is it higher on the top, which means it goes towards infinity or negative infinity? It does not exist. Or is it higher on the bottom, which means it goes towards zero? Or are they the same, which means it's going to be expression of the leading coefficients. So if we actually look at these problems here, you see an x on the top and an x squared on the bottom. So naturally you might think like, oh, that x squared's bigger on the bottom, it goes towards zero, which it doesn't. What you have to think about this is an x to the first on the top, and then on the bottom, it's the square root of x squared, which is also x to the first. So these are technically the same leading coefficients. Now, in order to figure out what this valuation is, to do it without a graphing calculator, remember, we can always go back and double check these on a graphing calculator. In fact, I would highly recommend doing that just to make sure you did this right, is to go through and divide. So what we're going to do here to make our life easier is we're still technically taking the limit here, but we're going to divide 3x minus 2. We're going to divide that by x. And then on the bottom here, we're going to divide the radical 2x squared plus 1. We're going to divide that by radical x squared, because technically dividing by x is the same thing as dividing by radical x squared. Okay, so what does that do to our equation? So what that does is basically turns this equation into, well, 3x divided by x is just 3. And then minus 2 divided by x is minus 2 over x. Not too bad. And then what it does on the bottom here, we'll make this one big radical because they're both radical. 2x squared divided by x squared is just 2. And then we got plus 1 over x squared. So if we think about this here, what's going to happen with these limits here? If I take the limit of 3, it's just going to stay 3. Technically, it's 3x to the 0 over x to the 0, and they match up. So that's 3. And then here, 2 divided by x, as that goes towards infinity, as this gets bigger, 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 that's going to go towards 0. On the bottom here, this is all inside the square root. We got 2. Same thing, just like 3, that's going to stay 2. And then 1 divided by x squared, as that gets bigger, bigger, bigger on the bottom, that's going to go to 0. So our answer here, our limit, I cleared everything, is just going to be 3 over radical 2, which ends up being, if we try to look fancy here, 3 radical 2 over 2. Okay. Now, how does this change when we're going towards negative infinity? When we go towards negative infinity, we are going to do the exact same process, but we do need to make a change because we are dealing with a square root. We don't have to do this when it doesn't have square roots. So we're still going to do 3x over 2 divided by x. On the bottom, though, we are going to take the square root here of x squared plus 1. We have to divide by negative radical x squared to make sure we're going towards the negative side. You only have to do this with the negative going towards a radical. And this is the only time. This is a very weird rule, and this is the only time you ever use this weird rule. Okay. And so it ends up being a very similar problem. So if we looked at the one before, we know, okay, those are going to cancel out. And this is going to be a 3 minus 0. And then over here, it's still going to be a radical, but since we have the negative on the outside, we'd have a 2 plus 0. So we get a very similar answer. It's going to be a 3 divided by negative radical 2, which ends up being negative 3 radical 2 over 2. So I would always recommend any of these square root problems to try to do it mathematically. In fact, you have to show your work mathematically if you want to get points on your homework or on your test. But what you want to do at the end is just to go through and verify on a graphing calculator. So using Desmos here to help us out, because that's been our resource for everything here. What's the equation? 3x minus 2. 3x minus 2. And we're going to divide that by square root of, oh, my Zoom stuff is getting in the way. Oh, Nope, that wanted to be on the bottom. Square root of 2x squared. It doesn't really matter, but plus 1. All right. Oh. All right, we can see this is what the graph looks like. You can see going to the right, it's different. Going to the right here, I'm gonna get a table just to help us out. All right, so I'm pick numbers 10, 100, 1,000, a million. Okay, so you can see it's going like 1.97, 2.1, 2.12, 2. Okay, and then let's even go backwards and let's just type a negative million. You can see it goes towards the same -2. What is that answer? We thought it was 3 divided by the square root of 2, which is 2.12. You can see that is basically the same number we have here. So that's how you can double check that you're doing it correctly. All right, so let's take a look at the homework problems, see what we need to deal with. Okay, so maybe we'll look at the ones that are on the left side. So just to kind of give you a hint, just to help you out. All right, so we look here. You can kind of use that same leading coefficient technique or the same value. This is degree 1 on the top. This would be degree 1 on the bottom. They are the same degree. So we're going to look at the ratios. This is a 1 on the top. And then since we're going towards negative radical infinity, it's going to be a negative radical. What's this leading coefficient? 1. So what's 1 divided by the negative square root of 1? That would be -1. All right, let's see the next one here. We got a 2x to the first power on the top. We got the square root of x squared on the bottom. Okay, so they are the same. Square root of x squared is still 1. All right, let's look at the leading coefficients. This leading coefficient here is 2. And over here, since we are going towards the negative infinity side, we'll put a negative radical. This leading coefficient is 1. What's 2 divided by the negative square root of 1? That'd be -2. All right, what about this one up here? Okay, we have a radical x squared on the, so that's technically degree 1. We have a degree 1 on the bottom. They're the same. We're going towards positive infinity here, so we don't need to change it all. What's the square root of? The leading coefficient is 1 over the leading coefficient on the bottom is 2. That would be 1/2. All righty, and let's see the bottom. Okay, the variable 33, we got a x to the first power on the bottom. And then what we have is the cube root of x squared. That would be x to the 2/3 power, right? All right, 1 is bigger than 2/3. So if it's bigger on the top, this just does not exist. And if you want to get fancy, you can go through and use the graphing calculator to figure out, okay, is that infinity or is that negative infinity? All right. All right, so that should help you guys out on tonight's homework. Remember, if they're the same, you just need to look at the leading coefficients. If you do have a square root, you got to check, are you checking the negative side or the positive side? That's going to change your radical here. And then also remember, the old rules still apply. If it's a bigger degree on the top, it does not exist. If it's a bigger degree on the bottom, it would be 0. Okay, so I hope that helps you out. Hopefully you guys can have some fun with this, and I will see you guys next time. Actually for the 3.6, which is probably the toughest section we do all year. Have a good one, guys.